The horizon of Helmand Province, Afghanistan, in the midsummer of 2008 was a shimmering, distorted landscape of alkaline dust and extreme heat. To an observer standing on the outskirts of a green zone patrol base, the vehicle approaching through the haze would have looked like an industrial accident in motion. It was not the familiar heavy silhouette of a tank, nor was it the slab-sided armored box of a standard troop carrier. Instead, it appeared to be a motorized scaffolding rig, a skeletal frame of tubular steel painted a flat, sandy tan, perched atop four massive, deeply treaded tires. It lacked everything a traditional soldier would associate with safety. There were no doors to provide a sense of enclosure. There was no roof to shield the crew from the blistering sun or the plummeting fire of an insurgent ambush. There were no thick, green-tinted ballistic glass windows to offer a barrier against the world outside. Instead, the four-man crew sat entirely exposed. Their helmets and ballistic goggles were caked in a fine, talcum-like substance known as moon dust, which coated every surface of the vehicle's interior. The driver sat on the right, his hands gripping a wheel that seemed connected to a machine far too light for the heavy weapons it carried. Above him, a gunner stood in a high-mounted ring, traversing a .50 caliber heavy machine gun that looked almost as large as the vehicle's front end. Beside the driver, the commander scanned the terrain with a general-purpose machine gun, GPMG, mounted on a swing arm, while a fourth man sat in the rear, facing backward with another machine gun, watching the six for any signs of pursuit or flanking maneuvers. To the media back in London, and to the concerned families of the soldiers inside, this vehicle was an affront to common sense. In a theater of war defined by the lethal, hidden threat of the improvised explosive device, IED, and the sudden, high-velocity crack of a sniper's rifle, the decision to remove almost all conventional armor seemed like a dangerous regression. It appeared that the British Ministry of Defense had sent its soldiers into one of the most hostile environments on Earth, in nothing more than a glorified dune buggy. It looked fragile, spindly, and dangerously vulnerable to even the most basic insurgent tactics. This was the mobility weapon mounted installation kit, officially the Jackal. But to the critics at home, it was a mobile coffin and a death trap. However, the visual lack of protection hid a revolutionary tactical reality. While the rest of the NATO coalition was retreating further into the depths of heavy, steel-plated boxes, vehicles that were becoming so heavy they could no longer leave the paved roads, the Jackal was doing the opposite. It was a machine designed for a different kind of survival. It traded the passive, heavy armor of the 20th century for the active, high-speed situational awareness of the 21st. It was a vehicle that remained unimpressive, even worrisome, right up until the moment it encountered the enemy. At that point, the Jackal transformed from a skeletal scout into a predatory weapons platform, capable of unleashing a sustained volume of lead and high explosives that exceeded the firepower of an entire standard infantry section. The Jackal was the British Army's most controversial and misunderstood vehicle of the modern era. It was a four-wheel Supercat HMT 400 that bypassed the traditional design bureaus to offer a radical solution to a lethal problem. To understand why this scaffolding on wheels became the most requested asset by frontline commanders, one must first look at the catastrophic failure of the vehicles it was destined to replace. A failure that was measured in lives lost and missions abandoned in the dust of the Hindu Kush. To understand why the British Army turned to a vehicle as radical as the Jackal, one must first confront the grim reality of the Snatch Land Rover crisis. By 2006, the British military presence in Helmand Province, Afghanistan, was undergoing a violent transition from a peace support mission to a high-intensity counterinsurgency campaign. The primary vehicle available for patrols at the time was the Snatch Land Rover, a machine originally designed for the urban streets of Northern Ireland. In the narrow, stone-walled alleys of Belfast or Derry, the Snatch's light composite armor was sufficient to stop low-velocity bricks, petrol bombs, and occasional small arms fire. but the dusty, open plains and green zone irrigation ditches of Afghanistan were not Northern Ireland. In the Hindu Kush, the Snatch Land Rover was catastrophically out of its depth. The primary weapon of the Taliban was not the petrol bomb, but the improvised explosive device, or IED. These were often massive charges constructed from ammonium nitrate fertilizer or unexploded Soviet-era ordnance, buried deep beneath the dirt tracks that served as the region's only roads. The Snatch Land Rover possessed a flat-bottomed hull and a relatively low ground clearance. When an IED detonated beneath it, the physics of the explosion were devastating. The flat floor acted as a catch plate for the blast wave, absorbing the full energy of the detonation and transmitting it directly into the cabin. The result was often the complete disintegration of the vehicle and the death or catastrophic injury of everyone inside. The British Ministry of Defence attempted to mitigate this by adding more armor to the Snatch, creating the Snatch Vixen and other variants. However, this created a new mechanical set of problems. The Land Rover chassis was never designed to carry several tons of additional steel and ballistic glass. The added weight pushed the engines to their thermal limits in the 50 degrees Celsius Afghan heat. Axles snapped, transmissions overheated, and the vehicles became dangerously sluggish. A Snatch Land Rover burdened with extra armor lost its ability to maneuver quickly, making it an even easier target for insurgent ambushes. Furthermore, the high center of gravity caused by the top-heavy armor made the vehicles prone to rolling over on the uneven Afghan terrain, leading to numerous non-combat casualties. The tactical dilemma facing British commanders was absolute. They could continue using the Snatch, which the soldiers had begun to call a mobile coffin, or they could move their troops into the newly arrived Mastiff and Ridgeback mine-resistant ambush-protected MRAP vehicles. The Mastiff was a massive, six-wheeled behemoth with a V-shaped hull that was incredibly effective at surviving IED blasts. However, the Mastiff brought its own set of failures to the battlefield. It weighed over 20 tons. It was too wide for the village streets and too heavy for the fragile mud bridges that crossed the Helmand irrigation canals. This weight restricted the British Army to the few paved or well-graded roads in the province. The Taliban, being a savvy and observant enemy, quickly realized this limitation. They stopped placing IEDs in the open desert and began concentrating their minefields on the specific routes they knew the heavy British armor was forced to take. The British Army found itself in a strategic straitjacket. They were either vulnerable in light vehicles or predictable in heavy ones. The soldiers were essentially trapped in steel boxes with very limited visibility, looking through small, thick windows that were often obscured by dust. This lack of situational awareness meant that by the time an insurgent was spotted with an RPG-7, the rocket was already in the air. The military needed a third option. They required a platform that possessed the cross-country agility to bypass the predictable road networks entirely, effectively outmaneuvering the IED networks by traveling where no road existed. They needed a vehicle that could carry an immense amount of firepower to end an ambush before it could turn lethal. And they needed a design that prioritized the crew's ability to see the threat before it struck. The solution would not come from the traditional, slow-moving defense giants, but from a small company in Devon that had spent decades perfecting high-mobility transport for the world's most elite special forces. The Jackal was not a compromise. It was a total rejection of the failed, armored box philosophy that was costing the British Army its mobility and its men. The transition from the Snatch Land Rover to the Jackal was not merely a change in hardware. It was a total pivot in military doctrine, moving from a philosophy of passive protection to one of protection through mobility. To understand why the Jackal was so revolutionary, one must look at the fundamental engineering contrast between a closed armored vehicle and the open architecture of the Supercat HMT 400 platform. On paper, a vehicle with steel plates and ballistic glass is objectively safer than one without them. In the sterile environment of a laboratory or a firing range, the armored box wins every time. But the reality of the Afghan green zone turned this conventional logic on its head. A closed vehicle, such as the Mastiff or the Snatch, inherently isolates its crew from the environment. The soldiers sit behind thick glass and steel, viewing the world through narrow slits or electronic cameras. In a counterinsurgency environment, this isolation is a tactical handicap. It creates a tunnel vision effect, where the crew is unable to hear the subtle changes in the environment, the sudden silencing of birds, the distant click of a radio, or the metallic rattle of an insurgent preparing an ambush. Furthermore, the thick glass of an armored vehicle quickly becomes obscured by the fine Afghan dust, reducing visibility to a fraction of what is required to spot a well-camouflaged IED triggerman or a pressure plate hidden in the dirt. The Jackal's open philosophy rejected this isolation. By removing the doors, the roof, and the glass, the designers at Supercat provided the four-man crew with 360-degree situational awareness. The commander and the gunners could see, hear, and even smell the terrain. This allowed them to detect the ground signs of an IED, slight discolorations in the earth, misplaced stones, or unusual patterns in the dust, long before a closed vehicle would have reached the kill zone. The Jackal's survival was based on the premise that it is better to see and avoid an IED than to drive over it in a heavy box and hope the hole holds. The contrast extended to the mechanical DNA of the vehicles. The Snatch Land Rover was a militarized version of a civilian utility vehicle. Its suspension, axles, and frame were adaptations of a design meant for farms and construction sites. When pushed to its limits by the weight of armor and the heat of the desert, it failed because its core components were being asked to do something they were never designed for. The Jackal, however, was built on the Supercat High Mobility Transporter, HMT, chassis, a purpose-built military platform designed from the ground up for elite special forces. The centerpiece of this chassis was a unique air suspension system that offered a capability unknown to traditional patrol vehicles: variable ride height. A Jackal could be lowered to sit close to the ground for high-speed stability on flat desert plains, allowing it to reach speeds of 130 kilometers per hour, far outrunning any insurgent vehicle. When it reached the broken ground of a wadi or the rocky inclines of a mountain pass, the driver could raise the suspension, providing a massive ground clearance that allowed the Jackal to crawl over obstacles that would have bottomed out a Land Rover or a Mastiff. Perhaps the most counterintuitive contrast lay in how the two systems handled an explosion. In a closed armored vehicle, an IED blast creates a massive internal overpressure. If the hull is breached, the shockwave is trapped inside the box, bouncing off the walls and causing catastrophic internal injuries to the crew's organs, even if they aren't hit by shrapnel. In the open-frame Jackal, there was no box. The blast overpressure had an immediate path of least resistance, up and out through the open sides and roof. While this left the crew exposed to secondary fragmentation, the primary killer, the pressure wave, was largely mitigated by the vehicle's lack of enclosure. This radical design was so effective that the American Special Forces, specifically Delta Force, quietly began purchasing the Supercat HMT platform before the British Regular Army had even placed its first large-scale order. While the British Ministry of Defense was still mired in the bureaucratic debate over the safety of open vehicles, the world's most elite operators had already recognized that in a modern guerrilla war, visibility and cross-country speed are the only true forms of armor. The Jackal wasn't just a different vehicle, it was an admission that the traditional, better-on-paper, armored box was a failure in the real-world complexity of 21st century warfare. The transition of the Jackal from a niche special forces tool to a mainstay of the regular British Army was an accelerated, often chaotic process born out of the Urgent Operational Requirement (UOR) system. While the Supacat HMT platform had already been proven in the secretive world of the SAS and SBS, its introduction to the wider infantry and reconnaissance regiments during Operation Herrick in Afghanistan was a shock to the system. The first Jackal 1 models began arriving in Helmand Province around 2007, and they were immediately handed to the sharp-end units, the Pathfinders, the Brigade Reconnaissance Forces, and the Light Cavalry. These were the units tasked with pushing deep into Taliban-held territory, far beyond the reach of the heavy Mastiff patrols and the static forward operating bases. The deployment of the Jackal immediately altered the tactical geometry of the Green Zone. Before its arrival, British patrols were largely predictable, tied to the main supply routes and irrigation crossings that their heavy armor could support. The Jackal changed this by enabling off-piste maneuvers. Because of its incredible power-to-weight ratio and its air suspension system, Jackal troops began traveling across the dashed, the open rocky desert, at speeds that the Taliban had never encountered from a Western force. They were no longer driving down the roads where the IEDs were buried. They were driving across the trackless wastes, appearing on the flanks of insurgent positions from directions that were previously considered impassable. However, this new mobility came with a steep learning curve. The Jackal was a complex machine that required a different kind of mechanical sympathy than the rugged but simple Land Rover. In the early months of deployment, the fine Afghan dust caused significant wear on the specialized air suspension bags and the high-performance Cummins engines. The heat was also a constant enemy. The Jackal's engine was packed tightly into the center of the frame to maintain a low center of gravity, which initially led to overheating issues during long-range patrols in the 50°C summers of Helmand. If you are enjoying this deep dive into the mechanical and tactical realities of the British Army's modern history, please consider subscribing to the channel. We focus on the engineering truths behind the systems that shape the modern battlefield. As the Jackal became a common sight in Afghanistan, it attracted a wave of intense media scrutiny. Back in the United Kingdom, the press began to label the vehicle a death trap. The argument was simple. If a soldier is sitting in an open-topped vehicle and is hit by an IED or a sniper, they have no protection. Every time a Jackal was lost, the headlines renewed their attack on the Ministry of Defense. But on the front line, a different perspective was taking hold. The soldiers using the Jackal, men who had experienced the claustrophobia and vulnerability of the Snatch Land Rover, were becoming its strongest advocates. They recognized that the Jackal was not a patrol car in the traditional sense. It was a high-mobility weapons platform. It allowed a small team of 4 soldiers to carry more ammunition and heavier weapons than an entire platoon of foot soldiers. In the long-range reconnaissance role, the Jackal was a revelation. It could stay out in the desert for days or weeks at a time, acting as a mothership for the crew. They slept on the vehicle, cooked on the vehicle, and used its massive battery arrays to power the sophisticated surveillance and communication equipment that allowed them to coordinate airstrikes and artillery from miles away. The Jackal didn't just move soldiers. It projected a level of persistent, mobile influence that the British Army had lacked since the start of the conflict. It was the tool that finally allowed the British to fight the Taliban on the insurgents' own terms of speed and terrain. The true measure of the Jackal's effectiveness lay not in its technical specifications on a manufacturer's datasheet, but in its firepower-to-man ratio, a metric that fundamentally redefined the capability of a light reconnaissance troop. In a standard British infantry platoon, a section of 8 men usually carries 2 light machine guns and their personal rifles. The Jackal, however, allowed a 4-man crew to wield an arsenal traditionally reserved for a heavy weapons company. This overloaded firepower was the primary reason a small troop of 3 Jackals could suppress and destroy an insurgent position that would have normally required an entire company of infantry and air support to neutralize. The primary armament of the Jackal 1 was centered around the main weapon ring, usually occupied by a .50 caliber M2 heavy machine gun or a 40mm Heckler Koch grenade machine gun, GMG. The .50 caliber gun provided the crew with the ability to engage targets with pinpoint accuracy at ranges exceeding 1,500 meters, allowing them to suppress insurgent firing points before the enemy's smaller caliber AK-47s were even in effective range. If the terrain offered heavy cover, such as the thick mud-walled compounds common in Helmand, the crew would swap the .50 caliber for the 40mm GMG. This weapon was capable of lobbing high-explosive grenades at a rate of 350 rounds per minute, effectively turning the Jackal into a mobile, high-speed piece of light artillery. The crew was organized to maximize this firepower in a 360-degree arc. While the gunner operated the main weapon, the commander, seated in the front left, manned a 7.62mm general-purpose machine gun, GPMG, on a swing arm mount. In the rear of the vehicle, a fourth crew member, often acting as the loader and scout, manned another GPMG, or a light machine gun, watching the vehicle's six. This meant that a single Jackal could suppress 3 different directions simultaneously. During a typical contact, a troop of 3 Jackals could maintain a base of fire so intense that it was frequently mistaken by the Taliban for a much larger force. The insurgents, who relied on shoot-and-scoot tactics, found that they could not move or retreat once the Jackals opened fire. The volume of heavy lead and explosive fragmentation was simply too consistent and too accurate. Technically, the Jackal was a triumph of high-performance automotive engineering applied to a lethal purpose. The Jackal 1 was powered by a 5.9-liter Cummins ISBE Euro 3 after-cooled turbo-diesel engine, which produced roughly 185 brake horsepower. While this figure may seem modest for a 6-ton vehicle, the engine was tuned for extreme torque, approximately 700 Newton-meters, allowing the Jackal to maintain high speeds even when overloaded with several tons of ammunition, fuel, and water. The Jackal 2, which began appearing as the mission in Helmand intensified, featured an even more powerful 6.7-liter Cummins engine. This additional power was necessary to offset the weight of the optional blast protection kits that were eventually added to the belly of the vehicle. The evidence of its survival capability was also found in the gritty, often horrific data of IED strikes. While the media focused on the lack of a roof, the Army's internal reports began to show a curious pattern. In many instances where a Jackal triggered a large IED, the fatalities were lower than predicted. This was attributed to the Jackal's open architecture and its specialized blast seats. The seats in a Jackal were not bolted directly to the floor. They were suspended from the tubular frame, which helped isolate the crew from the initial slam of a mine detonation. Because the vehicle lacked a roof and doors, the massive overpressure of the explosion, the primary killer in a closed cabin vehicle like the Snatch, was allowed to vent instantly into the atmosphere. While the crew was certainly vulnerable to secondary fragmentation and being thrown from the vehicle, they were far less likely to suffer the catastrophic internal organ damage caused by trapped pressure waves. The Jackal proved that sometimes, in the violent physics of an explosion, a cage of steel is more dangerous than an open frame. The success of the Jackal in the valleys of Helmand ensured that it would not remain a temporary wartime curiosity. As the conflict in Afghanistan matured, the Ministry of Defense moved the Jackal from an urgent operational requirement to a permanent part of the British Army's core equipment program. This transition led directly to the development of the Jackal 2 and its larger, 6-wheeled sibling, the Coyote. The Jackal 2 was a more refined, industrialized version of the original design, featuring the larger 6.7-liter Cummins engine and a reinforced chassis that could better handle the stresses of long-term operational wear. More importantly, it incorporated improved blast protection for the fuel and electrical systems, and a redesigned crew compartment that allowed for the integration of even more sophisticated electronic countermeasures to jam insurgent IED triggers. The expansion of the HMT platform reached its peak with the introduction of the Coyote Tactical Support Vehicle, TSV. By adding a third axle to the Jackal chassis, Supacat created a 6x6 vehicle with a significantly increased payload capacity. The Coyote acted as a mothership for Jackal troops, carrying the massive amounts of extra fuel, water, and ammunition required for long-range reconnaissance patrols that could last for weeks without resupply. In some configurations, the Coyote was even used as a platform for 81mm mortars, providing a Jackal troop with its own mobile, organic, indirect fire support. This combination of 4x4 scouts and 6x6 support vehicles created a highly mobile, self-sufficient force that could operate in the most remote regions of the world. As the British mission in Afghanistan concluded, the Jackal found new roles in vastly different environments. In the forests of Estonia, as part of NATO's enhanced forward presence, Operation Cabret, the Jackal proved that its mobility was not limited to the desert. Here, the light cavalry regiments used the Jackal's low ground pressure and high speed to navigate wooded terrain that would have bogged down heavier armored vehicles. The role also evolved from counterinsurgency to conventional deterrence. The Jackal was integrated with the Javelin anti-tank guided missile, turning the high-speed Scout into a lethal tank killer. In this role, the Jackal's speed was its primary defense. A crew could hide in a tree line, launch a missile at an enemy main battle tank from 5 kilometers away, and be miles from the firing point before the enemy could coordinate a counterstrike. The influence of the Jackal can now be seen across the global military landscape. The high mobility transporter concept has shaped the development of the American Ground Mobility Vehicle, GMV 1.1, used by U.S. Special Operations Command, as well as various light strike vehicles in France and Germany. The British Army has fully embraced the platform, with the Jackal now serving as the primary vehicle for the light cavalry, the Royal Air Force Regiment, and specialized units like the 16 Air Assault Brigade. It has been deployed to the deserts of Mali, Operation Newcomb, and the cold weather training grounds of the Arctic, proving that the philosophy of protection through mobility is a universal principle of modern warfare. The Jackal did more than just replace the Land Rover. It created a new category of military capability that prioritizes the soldier's ability to see, move, and strike over the outdated reliance on static, heavy armor. The Jackal replaced a failed Land Rover with a predatory legend. It proved that visibility and speed are the true armor of modern war. In the dust of Helmand, it was the soldier's greatest revelation.